Hello, welcome back. The title of this lesson is called the Distributive Property with Variables. This is part 1. So here we're going to go over one of the most important properties that you will use in math basically forever, and it's called the distributive property. First, we'll review it, then I will explain the distributive property using only numbers so that you can understand it and there's no variables involved. And then once we understand it, we will apply it to situations where we have variables. That means letters that we have running around all of our problems, right? Now, keep in mind that the distributive property, we're going to use it forever. We're going to use it when we simplify expressions in algebra. We're going to use it when we solve equations. We're going to use it way down, even beyond algebra, into geometry and calculus and trigonometry. We're going to use it forever. So let's take a look at what is this distributive property anyway. What does it mean when you distribute something? If there's 6 people in front of you and I tell you distribute a loaf of bread among these 6 loaves of bread among these 6 people, what does it mean? He gets a loaf of bread, she gets a loaf of bread, he gets a loaf of bread, so on. You go and you give those loaves of bread out, or whatever you're distributing, equally among those people. So the distributive property is a bunch of words, right? Multiplication into the sum or difference of terms is equal to the sum or difference of multiplication with each term. Lots of words. Most people fall asleep when they read words like this. What it's actually telling you is that if you have something, we'll call it A, but A could be anything. It could be a number or it could be a variable like this. And it's multiplied by a parentheses term with something added. I want you to ignore this for now down here. Then what it means is A gets multiplied or distributed into everything on the inside of the parentheses because you have A times this thing in the parentheses. And so since there's 2 things in there, it must be multiplied to the B term and then distributed in and multiplied also times the C term because A is multiplied by both of them wrapped up in the parentheses. So we have A times B here, and then we have A times C here. And so they're multiplied and they're added together because there was a plus sign that was linking the B and C. What if you have a minus sign here? Then the A gets to be multiplied times the B, and it gets also multiplied times the C. But now there's a minus sign linking them because that is what was present in here. So when we distribute something from the outside of a set of parentheses into the terms on the inside, then we multiply times every term that's on the inside of the parentheses. And if there's a plus sign, it's linked with a plus sign, and if there's a minus sign, then it's linked with a minus sign. So let's understand how this works, first of all, with just numbers, because it's so easy to check and verify that this is true. What if I ask you, what is 2 multiplied times parentheses 2 plus 3? Now, we know how to do this with order of operations, but let's do it with the distributive property. What we are basically saying is that since we have 2 multiplied by this parentheses term, the outside 2 gets distributed in and gets multiplied times the first term, but it also gets distributed in and multiplied times the second term. So what we have is 2 times 2 from the first term, right? We'll do the multiplication later. And then we have a plus sign because that's what's linking it, and then the 2 gets multiplied times the 3. Right? Now, forget about the left-hand side. Now let's focus with what is on the right-hand side. We follow order of operations. We know the multiplications always happen before the additions, right? Because we do exponents, we do parentheses, and then exponents, and then multiply, divide comes next before any addition or subtraction. So 2 times 2 is 4, and 2 times 3 is 6. So we do the multiplications first, then we finally add, and 4 plus 6 is 10. Now, that was how we do it using distribution. Let's go back here and do it using order of operations here. Here we have parentheses term. We do that first. Inside 2 plus 3 is 5. And we're still going to multiply that times the 2. We do the multiplication last. 2 times 5 is 10. Notice we get exactly the same thing. So what I'm trying to tell you is that if you have something multiplied by the sum, things either added or subtracted in parentheses, if you calculate it, you get something. But if you distribute it into each term on the inside and calculate it using the distributive property, you get the same answer. That means that what this is saying is true. It's proving to you with numbers that this is true. When you have something times a parentheses with something linked by a plus sign, you just bomb it in. You know, the little arrows, you can think of it as little bombs going in and bombing every little item that's inside there, every little term. Multiply times the B, multiply times the C, and they're linked with a plus sign. Now, what happens if you have something linked with a minus sign? And after this one, we're going to do it with variables. as well with letters, right? Let's say we have 6 multiplied by 2 minus 1. Well, let's use the distributive property here. We're going to have this 6 multiplied in times the 2, and then also multiplied in times the 1. It gets multiplied into each interior item. 6 times 2 is here. But a minus sign comes along because this is a minus sign here. And then 6 times 1, the multiplication of the second item in there. So it gets distributed into everything on the inside. Again, multiplication comes first. 6 times 2 is 12. 6 times 1 is 6. And then finally subtraction, 12 minus 6 is 6. Now, if we go back to our original problem using order of operations, we do what's inside of the parentheses first. 2 minus 1 is 1. And we still have to now multiply by the 6. 6 times 1 is 6, and we get the same thing. So you see, no matter if you have a plus sign linking the items on the inside or the minus sign linking the items on the inside, you can always distribute what is on the outside and multiply every little interior term, linking it by whatever you see here, whatever plus or minus you see. And what you get when you do that distribution is exactly the same answer as what you would get if you didn't use distribution and used regular order of operations. All right, now why do we care about this? Because with numbers, it's quite easy to check ourselves, but let's take the training wheels off a little bit. And let's say we have 2 multiplied by x plus 3. Now notice that here when I had 2 parentheses 2 plus 3, I did not have multiplication symbol between the parentheses and the 2. I did not have a multiplication symbol here either, and I did not have a multiplication symbol here. In algebra, you need to start to realize when you have 2 things written right next to each other and there's no multiplication symbol, then you assume that they're multiplied. So here it's 2 times this term that has the parentheses. So what do we have here? We have distribution. We're going to distribute times the x, and then we're going to distribute times the 3, and it's linked with a plus sign. So what we're going to have is 2 times x is 2x, and then we have a plus sign because the plus sign is linking it, and then 2 times the 3. So I'll write it as 2 times 3. Now, we know how to multiply 2 times 3, so we can write this as 2x plus 6. The answer is 2x plus 6. Now you might say, okay, how do I turn this into like a single answer? Isn't this plus sign? How do I get rid of this plus sign in the answer? And the truth is you have to get used to seeing plus signs as you get into algebra in your answers. We cannot do anything further here, and we're going to do a lot more very soon with explaining why. But basically, you cannot take 2x and add it to 6 because they're different terms. One of these terms involves an x, and this term involves no x's. So the only time we can really add or subtract things in algebra is if the terms are the same. But if I give you 2 elephants and 2 bananas, you can't really add them together. I mean, you could 2 plus 2 you could say is 4, but you're adding elephants and bananas. What are you adding? You're adding completely different things. You would then say you have 4 objects, which is like the general thing that you're adding together, 2 different objects, right? But because they are different, elephants and bananas, you really can't add them and have the answer make a ton of sense. Here you have bananas, 2 times x is like 2 bananas, and here's like 6 jellyfish. Well, you could add them, bananas to jellyfish, but they are different items, they're different classes. So in algebra, you can only add things if the variables match, and the exponents as well. We'll talk about exponents later. Here we don't really have exponents to worry about, but the variables definitely have to match in order for you to add them. So if you see 2x plus 6, this is a straight number, and this is a number times a variable, and we can't add them because they're not the same. And you need to get used to seeing that. All right? Now, what have we really said here? What we've said here is that this expression, 2x plus 6, is exactly the same as this. Mathematically is the same thing. Let's just check for a second and see if it is the same thing. What if we say, remember the variable x, a variable can take on any value, right? We don't know what it is. It could be 0, it could be 5, it could be negative 17, it could be 1/2, it could be 3.69, whatever. We don't know. So let's just check by picking a convenient value for x. So let's say x is 0. If x is 0, then I'm going to have 2 times 0, which is 0, and then I'm going to add 6, and I'll get 6. So if x is 0, this calculates to be 6. If I put 0 into here, then what is 0 plus 3? It's just 3, right? And because we do what's on the inside. And then 3 times 2 is 6. So if we put the value of 0 in, then this thing turns into a 6, and this thing also turns into a 6. So we know that they're the same thing, right? Let's check it with another value of x. Let's put the value of 1 here. 2 times 1 is 2, and then 2 plus 6 is 8. So that would turn into an 8. What if I put 1 here? 1 plus 3 is 4, and then this 4 times 2 is also 8. So if I put x as 0, or if I put x as 1, then this little expression, even though it looks different, actually means exactly the same thing as the other one, right? And we've only shown you 2 little values of x that you put in there and prove that to yourself. But if you put any number you want, you will always find that they're the same thing. That's why we have this thing called the distributive property, because it means for any value of a, and for any value of b, and for any value of c, no matter what they are, this little expression is going to be the same as taking a times b and then a times c and then adding them together, because this is always equal to this, no matter what values or what your problem is. And so that's why when we bomb this in and distribute it in and we come up with this as an answer, we say that they're equal because this is exactly equivalent to this. It's like fractions. You know that 1/2, right, of a pizza, you know what a half of a pizza looks like. But if I tell you 5/10 of a pizza, 5 slices out of 10, you know it's the same thing as 1/2. Or 4/8 of a pizza, you know it's the same as 1/2. Or 15/30 of a pizza, 15 out of 30 slices, you know that's also a half. They look different, but they all mean half a pizza. So this looks different, but it is the same thing. Now that's a bunch of talking, but it's important for you to know how absolutely critical the distributive property is. And so that's what I wanted to get across to you. Problem number 2. Let's say we have 4 times 7 plus h. So we're going to multiply in, right? What is 4 times 7? And then we're going to do 4 times h. And we're going to link it with a plus sign. So what do we have? 4 times 7. Plus sign comes from here. 4 times h. You could put a dot here if you want, but you don't need to, because when you write 4 right next to h, it means they're multiplied. So now what is 4 times 7? It's 28. And then we have 4 times h. We can't do anything further with this because we don't know what h is. So we have to leave it as 4 times h, whatever h is. H can be 1, h could be 2, h could be -19. I don't know, because I don't know what this problem is for right now. But later on, when you solve for the trajectory of a baseball, then maybe h is the height of the baseball. Or maybe h is how far away Pluto is from the sun. H is going to have some meaning in real life, but for this, we don't know what it means, so we just have to keep it as 4 times h. Now, the last thing I want to say is when we have 2 things added together, we usually want to write the term with the variable first and then any just numbers by themselves at the end. Would you agree that this is the same as this? Well, they're added together, right? What is 2 plus 3? It's 5. What is 3 plus 2? It's also 5. So because of the commutative property we learned before, we can flip the order of any 2 things that we add together. So 28 plus 4h is exactly the same as 4h plus 28. And this is just like a convention. People just do it. But we usually write the terms with the variables first and then any just numbers off as the last terms, even though it's exactly the same as what we have written up above. All right, let's take a look at 8 parentheses c plus 6. So what are we going to have? Well, we're going to be multiplying times the first term, which is a c, 8 times c. We could put a dot there, but we know they're multiplied by writing them next to each other. The plus sign comes from right here, and then 8 times 6. 8 times 6. And so 8c, and then 8 times 6 is 48. We cannot combine these any further because this is a term that has a variable c, and this is a term that's just a number. They are unlike terms. The only way you can add them, and we will learn this later, is if the variables match. There's a couple of other issues we have to talk about, but the variables have to match. Here, the terms are not the same because there's no c here. Here, the terms are not the same because there's no h here. And here, the terms are not the same because there's no x here. So we can't really add them any further, right? We just have to kind of like leave it be. Now let's just check this one, because we're not going to do for every one of them, but let's just check this. Let's just see if these are the same. What if we put 0 in for c? C can be any value I want. If I put 0 here, 0 times 8, that's just 0, and I'm just going to get 48 as the answer. If I put 0 here, then 0 plus 6, that is 6, and then 6 times 8 is 48. So if I put 0 in, I get exactly the same thing on the left and on the right-hand side because those are exactly the same expression, even though they look different. All right, let's take a look at the next problem. What about 2 parentheses j plus k? Now this one is a little bit different because on the inside of the parentheses I have j plus k, which are 2 different variables. It's perfectly fine to have 2 different variables in the same problem. In real life, when we start to solve real problems, think about the trajectory of a baseball. We might have h, which is the height of the baseball above the ground, and we might have t, the time that it takes to get to the end of the flight. So t and h might be 2 different variables in the problem. When we're talking about a spacecraft orbiting Earth, we might have one variable, v, for velocity of the spaceship, right? And another variable, h, for the height above the ground. And another variable, I don't know, g, for gravity that's happening inside your ship. Or maybe there's no gravity, depends on the problem. But we don't get scared by this because we're still going to distribute in to everything on the inside. It's the same exact rule. There's nothing that changes here. So what do we have? 2 times j, we just write it as 2j. They're multiplied together even without a dot. The plus sign comes from here, and then 2 times k. So here we have 2 times j plus 2 times k, right? Now what this means is that if I pick a value for j, and I pick a value for k, and I lock them in place, and if I put some known value for j and some known value for k here, and then the same values for j and k here, I'm going to get the same answer. Let's just try a quick one. Let's say j is 1 and k is also 1, just to make it easy to remember. 1 here and 1 here. 2 times 1 is 2. 2 times 1 is 2. 2 plus 2 is 4. Right? What if I put 1 and 1? Then 1 plus 1 is 2. Then this 2 times 2 is 4. I get exactly the same thing no matter what values of j and k I put in, as long as I use the same values, because this thing, even though it looks different, is really the same exact thing as this thing. Now, it doesn't matter the order that I write these because they both have variables. You see, we usually like to write the variable term first and the number constant term second, but here both terms have variables, so it's fine just to leave it exactly the way we have it there. All right, next problem. Let's say we have 3 times b minus 3. So here we have our first minus sign, which is right here. So let's multiply and see what we get. We have 3 times b, which is 3b. That's because we multiply right here. A minus sign comes from this minus sign here, and then the 3 times the other term, 3. So we write 3 times 3. And then we have 3 times b right here, and then 3 times 3 is 9. 3b minus 9. And this is the final answer. Notice that we have the term with the variable first, then a minus sign, then the number term. That's the way we want to write it. We generally want to write the term that has the variable first, and then any number terms will just follow it, like that. All right. Moving right along. Let's say we have 5, parentheses, 6 minus h. All right, what do we do? Well, we're going to distribute in. The 5 times 6 is going to be written as literally 5 times 6. The minus sign will come along from the inside, and then 5 times h. You could put a dot there if you want, but when we write 5h right next to each other, we know they're multiplied. 5 times 6 we know to be 30. 5 times h is here. Now, you can leave it like this. There's nothing really wrong with it, but like I say, usually we like to write the terms that have the variables first. So the 5h needs to come first, but the minus sign the sign directly in front is kind of attached to it. So really it's negative 5h. And the sign in front of the 30, this is a positive 30, so it goes along with the 30. So this is how you write it if you're going to flip it around. If you want to write it like this, I guess it's okay. Usually you want to write the term with the variable first, and then the number term second. The sign in front of the 30 is, there's an invisible plus sign, so we have a plus sign here. The sign, which is a minus sign that goes with the 5h, means it's attached to it. And so when you're rearranging terms, you need to make sure and grab the sign that is right in front of whatever it is you're moving around, because the sign, or the plus minus that's in front, is attached to, it's like a chain. This is like a train, and these little pluses or minuses are linking the next car in the train. So if I move this car up here, I have to cut off the sign with it and bring it with. I mean, that's just something you're going to have to get used to. All right. Let's take a look. Almost done. What about 3 parentheses, w minus d? So again, we have 2 variables on the inside. 3 times w, we just write it as 3w. Minus comes along from here. 3 times d is 3 times d. So we have 3w minus 3d. And we can just leave it like that because we have a term with the variable and a term with the variable. So we could flip it around if we want, but there's no real need to, so we'll just leave it the way it is there. All right, only a couple more problems. Let's take a look at x, parentheses, y plus 2. All right, like this. So the first term that we're going to have is x times y. Now we have two variables multiplied together. I don't know what x and y really is, but I know they're multiplied together, so I'm going to write x and y right next door. I can put a dot if I want to show multiplication, but if I write it with nothing in the middle, I know that they're multiplied together. Then the plus sign comes from here, and then the x gets multiplied times 2. So you could write it as x times 2 if you want, I guess. You could write it as x times 2. But we don't usually write x times 2. We usually write it as the number first followed by the letter. So we don't say x times 2. Usually we say 2 times x. Remember, when you multiply things, the order doesn't matter. If you have 3 times 4 and that's equal to 12, it's the same thing as 4 times 3 is 12. When you multiply, the order doesn't matter. So x times 2 is the same thing as 2 times x. Now, if you wanted to, you could write this in front. You could say 2 times x plus xy, because 2x can go here with its plus sign, xy can go here with its plus sign, and you could write it like this, but really this is fine above as well, because you just want to have a term with a variable first, and this term has variables there as well. So you can write it either way in my book. This is fine or this is fine. Either way is fine. Now, if I were to pick a value of x and a value for y and put them in here, and then put the same values for x and y here, and I calculate the results, I'm going to get exactly the same answer. All right, only 2 more. Let's take a look at z, 4 minus j. How do I distribute that in? Well, I'm going to multiply here z times 4, which you can write it as z times 4, but again, usually we don't do that. We write the number times the letter. So really, when I say z times 4, I'm going to mentally flip it around and make it 4 times z. And then the minus sign comes from there, and then z times j. You could write it as j times z if you want as well. Like you could flip this around, make it j times z. It's exactly the same thing. So 4 times z, we like to write the number first. And then z times j, I have it here, but you could write it j times z. It doesn't really matter. 4 times z minus z times j. All right, and then we have our very last problem. I think I'm going to do that one over here and call it a day. What about c, parentheses, d minus f? So here we took all the training wheels off, and we don't have anything other than numbers. That's all letters. That's all we have here. So we multiply times the d, c times d. Minus sign comes from here. C then gets multiplied times f, c times f. Now again, if you wanted to, you could flip this around and make it d times c. You could flip this around and make it f times c, because flipping the order of multiplication doesn't matter. But here I'm going to write it as c times d minus c times f. And now you can start to see from the beginning of the lesson to the end of the lesson how powerful the distributive property is. Because when I show you problems like this, everybody can understand that this is equal to 10. And when I blow it out in distribution, it's also equal to 10. And so a lot of students say, well, great, why do I care about that? Because it's so obvious, right? But then if I change and I don't have any numbers anywhere and only letters, and if I tell you this is the same exact thing as this, most people, unless they start working with algebra a while, will not understand why this is the same thing as this, because it looks too different, right? But I promise you, if you pick a value for d, and if you pick a value for f, and if you put a value for c into here and calculate, and you put the same values for d and f and c in here and calculate, then you will get the same answer on the left and on the right, as I've shown you many times before. So why do we use distributive property? Because it helps us later on solve equations. We might have an equation that's written like this, but I might need to blow it out like this in order to solve it. So later, that's where we're skating to. We're giving you the skills so that we can then solve equations and graph things and understand things in the real world. We might have a spaceship on the way to Pluto, right? And we might know its velocity, and we might know how long it's been in space. Those are different variables. We might know, the shape of the orbit. The eccentricity of the orbit could be another variable. There's all kinds of ways in which we can use these things to model the real world and calculate when this thing is going to get to Pluto. And learning how to manipulate expressions that have variables in the right way, using these properties helps us solve those real world problems. So I know in the beginning it's kind of hard for you to see because we're not solving anything real here, and so maybe it looks a little boring, but I promise you, all of these skills will be used as you continue learning to solve more and more complex problems in the real world. So solve these yourself. Make sure you understand the concept of distribution. Follow me into part 2. We'll get a little more practice.